No, yeah, I agree. All right, so there was no championship. Hey guys, I'm recording. Hey kids, let's go blue Michigan Grand Champs. Who's got better than us? Nobody. All right, let's go. All right. Speaking of exponential growth of what?
She's on recording right now.
I'm recording. This is important. I'm sending this. I'm live streaming to the new superintendent. All right. So we know how to solve inequalities, or we have a good idea how to start these now, right? So let's make them easier by adding inequalities. So when you solve inequalities and your b is greater than 1, that means that b of x is less than b of y if x is less than y. We're going to see what this means in a second. We're going to do it differently, or look at it differently if it's decreasing. So if my b is less than 0 or 1, they act differently. Best way I can do this is let's just do some examples and find out. All right, we have an inequality here, right? I'm going to start by solving it. You guys remember in algebra, you always start by just treat it like an equality, right? Is there a way I can rewrite 125 as a power of 5? That's 5 to the third. Do you all agree on step 1? Now, look at this. This says, is my b greater than 1? Is 5 bigger than 1? Yeah. If b is bigger than 1, what can I do with my exponents once they have the same base? I can just set it up, right? Yar or nar? Okay. So I'm going to do x is greater than 3 times x plus 6. So x is greater than 3x plus 18. Yar? With which part?
X is greater than 3x plus 6.
We're just stealing. We're stealing that. No, because it's the same for both. This is where things are going to get a little bit tricky. So now when I solve this, right, what do I get? Let's solve it. So I get negative, I wouldn't do it this way. I'm going to do this. Negative 2x is greater than 18, right? So I get x is less than negative 9. Yar? Actually, it is. That's 100% right. All right. So we solved it, right? Could I say this is negative infinity and negative 9? Are these the same thing? Yes. Now here's the big question. How would I verify this answer with a graphing utility? How do you, hold on guys, I want you to think about this for a second. How can I verify inequalities with a graphing utility? You plug in both. I would actually, you don't even have to plug in both these. Can I plug in both these? Yeah, because if the base is the same, all I care about is this. So if I graph y equals x, right? That's y equals x. Agreed? And I could graph 3x plus 18, right? So that's going to be like up here. It's going to look something like that, right? Hey, I should just use purple. If I graph that in my calculator, where do they intersect at? -9. I care about when is 5 to the x. Hold on, Mr. Twillier. Oh yeah, great. When is 5 to the x greater than that, right? So when is the y equals x line above it? Is it above it when you're greater than -9? It's above it when you are less than -9. So does that verify what we just found? Yeah. When is the purple line higher? When we're less than -9. All right. Long day. I like the Barney colors today. Let's use a different property. The biggest thing I want you guys to realize is, do you understand how I got from here to here?
Yes.
Same base. It's just like with inequality, right? Do I have any extraneous solutions with these if they're exponentials? No, because I can plug anything into an exponential. All right. Jiminy Crickets, y'all. I cannot think. I'm tired from flying in from the game. All right, let's look at this beast. What makes this different from the one up above? What's yours look like? It should be 1/27 to the x minus 3. I don't know if this helps. Right away, my bases are between 0 and 1 now, right? So because of that, we're going to treat it differently. We have to flip our sign, right? So for this one, can I rewrite 1/27 as a power of 3? Yeah. I'm like, or I could just do 1/3 to the third, right? To the, that's a lot of parentheses, but I'm just changing that to 1/3. Now that I have the same bases, what can I do with my top parts? But now, because this is less than 1, what do I have to do with my sign? Flip it, right? If your base is between 0 and 1, you have to flip your inequality. If your base is bigger than 1, you just keep it. And that's because this is a fraction and it's a negative. Technically, we're dealing with a negative, and because of that, it's flips your sign. All right. Now this is good old-fashioned algebra, right? 2x plus 9 is greater than or equal to 3x minus 9. X is greater than or equal to 18. Or is less than or equal to. I skipped a bunch of steps. Can I rewrite that as negative infinity to 18 with a bracket?
Yes.
Because it's or equal to, so we have a bracket. Yes, these mean the exact same thing. This is you. Oh well, no. Oh, if you use parentheses, no, it's wrong. Use if you want to, yeah. I'm not going to verify it. Don't tell on me. Okay. So are we good? Bigger than, so we solve it just like we've been solving. If it's bigger than 1, you keep the sign. If it's less than 1 and greater than 0, you switch the signs. Sound good? All right, what about with logs? Yeah, whatever. So sue me. If I'm doing logs and my bases are greater than 1, I keep the sign for what's in the log. If b is between 0 and 1, what do I do with my sign? I flip it.
Why are those separate?
They're the same but opposite. So it's the same though as the original, right? If b is a growth, we keep the sign. If it's a decay, we change the sign. Let's do it. This isn't too scary. I'm not used to reading analog time. All right. Uh-oh. I have log base 2 and log base 2, but what do I do with that 2? Can I do anything with it yet? I got to put it at the end, right? So I got to rewrite this. I just need the logs by themselves. Do they have the same log base? Is that base greater than 1? So I can just do this, right? Y'all agree?
What's greater?
How do you get rid of x squared? I'm going to square root. So I end up with 3 is greater than x, and I end up with negative 3 is greater than x, right? Because when I square root, I get the plus or minus, right? Now think about this. Can x be less than negative 3? Why not? Can't take a negative log. So this is my only solution, right? Or I could have written from 3 to infinity.
See, we have to write that.
Oh, I'm not. Hold on, that's not the answer. What can't I do? X is less than 3, but what can't x be less than? Can it equal 0? Nope, can't. Can't. A number to a power can't equal 0. Why did I add the 0? Because it's a log. We can't go below 0. My bad. That's better. I knew it when I went to write negative infinity. I'm like, that's no bueno. Let's get tricky, y'all. Yeah. Let's get tricky. Tricky, 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 tricky. Why did I keep that the same? Because 2 is bigger than 1. Can't log a 0. Ooh, look at this. Uh-oh, Mr. Twiggler. I'm scared. I'm tired. And I love pre-calc. What do I do with this? Do they have the same log with the same base? Uh-oh.
Yeah, there's 2 and then there's 2 and then here. So like cancel it out.
Actually, can I just use my power? Can I use my solving rules on inequalities? How would I get rid of a log if it's only on one side? Yeah. What should my base be? Can I do that? Can I do it?
Yeah.
I just did. Try to stop me. Come at me, bro.
Yeah. Well, I know
No, this is it. It is what it is. I don't know.
This is 2 and then 2 and then 2. 2 is 2 and then 2 is 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 2. 2 is 2 and then 2
Yeah, that's right. So what's this become? 8?
Yeah.
Okay. Oh. I'll throw the curveball at you after I solve this. Some subtract 1, right? 2x is less than or equal to 7. So that's okay. I'm just going to change to 3.5. Yay! Hold on though. Can x be negative?
No.
But when I plug in 0 for this, I get 1. So could I plug in some negative numbers? Let's sidebar this. Let's talk for a second. So I know this is true, that this has to be less than 8, right? What else has to be true about this equation? Side bear? Whoa. What else has to be true about 2x plus 1? Has to be positive. Are you sure? Positive. So I also know this has to be greater than 0. So I have 2 equations I got to solve.
Oh.
Can you have a question? Yes. I keep it. I keep it the same. It's on the left side. Yep, I keep them. I'm solving it just like an equation. I'm not flipping them. This one, though, I could have wrote either way because it doesn't matter. I'm going to solve it good old-fashioned mathematical style. X is greater than negative 1/2. Right? I could have done that with the original one, but the original one just had a basic x, right? It was x squared. So x squared, when's x squared greater than 0? When x is greater than 0.
I don't know what I do the side version.
You can't take log of a negative. You don't have to do this with exponentials because you can plug in a negative.
Because x is less than or equal to 3.5.
Yeah, actually, if I got this was x is greater than or equal to 3.5, would I even have to do this? Because 0 is not part of it. You know what I mean? So yes, you have to do it if you get a less than over here. You know what I mean? So x has to be greater than 1/2. Let's make it a decimal because let's be consistent. So that means x has to be greater than negative 0.5 and less than or equal to 3.5. This is where I like doing brackets better, right? I could have negative 0.5 to 3.5, right? What? Better now? Is it good? No brain change without stress. Only if you get a less than over here. Because you can't take natural log of a 0.
So
No, absolutely not.
they don't have to know. In the parentheses sidebar.
No, you won't.
Oh, well,
Whoopsie.
every single time the parentheses has to go to the sidebar, it's less than 0.
If you get a less than. Yes. Yeah, I should probably look up what it looks like. Pretend like you don't. Study like you don't get it. Whatever. You do more extra practice. Use practice. How do you get better at shooting? How do you get better at shooting a shot? All right, so here we go. Hey, look at this, y'all. Are my bases the same? They're less than 1. So what do I do with these 2 pieces? What do I got to do with them? You got to flip it. Flip it like you guys flip me off whenever I turn my back because you love this class so much. You heard it here first, folks. All right. Are we good on this? Okay. So what do I get here when I solve it? I get, gross. Less than or equal to 8, right?
Wait, you flip it because the base?
The base is less than 1. Yep. Yep. So we flip it. So I get x is less than 8. But wait a second.
Oh, because it's less than, yeah. So
Wait a second. Wait a second. X is less than 8. Does that encompass negative numbers, like negative infinity?
Yes.
Uh-oh, SpaghettiOs. Sidebar. So what do I have to know about this piece? 2x minus 3 has to be greater than 0, right? Also, x plus 5 has to be greater than 0. Right?
It's pretty proper.
No, it's not. It makes you feel that way. All right, so let's solve it. So I get 2x is greater than 3. X is greater than 1.5, right? And here I get x is greater than negative 5. Which one of these is more inclusive? What I'm saying by that is, for this equation, does negative 4 work? Does negative 4 work for that one? So this one we're going to disregard.
How do I want to do that? So it's 1.5.
Because, no, hear me out, hear me out. Negative 4 works for this one, but does it work for this one? Does negative 4 work for this? I picked a number that's bigger than negative 5.
Oh.
Wait, hold on. Does everything that works for this work for this one?
Yes. Yes, it does.
Does 2 work for this? 3, 4. But does everything for this one work for that one?
No.
So that's why we have to do that one, because it includes both. It's the most inclusive because it has the least amount of numbers. Inclusivity in math means you have the least amount in it. No, I stand by what I said. That's what inclusivity in mathematics means.
So the number it gives
The one that will work for both equations is 1.5 greater than negative 5.
Yeah.
But is negative 4 greater than 1.5?
No.
That's the one that works for both.
Oh. These are a lot of rules.
Just like driving. You guys can pass, if you can pass a driver's test, you can pass this.
That's very different. At least you fell asleep during my drive.
Let's go. No names.